powerful technology of our time was a complete and utter failure, a scientific dead end abandoned by the world's top researchers. The story of how AI survived that near-death experience is one of the most incredible in modern history. In fact, everything you just saw and heard
is AI. This person is not real. His voice is not real. He was generated by an AI from a single photograph. We live in a world where reality can now be fabricated perfectly. This technology, known as deep faking, has moved beyond a niche hobby and is now so powerful, so accessible, that it poses a fundamental question. When our eyes and ears can be so easily fooled, what can we trust? The AI that created this illusion seems to have appeared overnight, an unstoppable force. But this future was never guaranteed. In fact, it was almost dead on arrival. To understand how we got here, we have to go back to a time when AI was considered a scientific joke, a dead end so profound it triggered a 20-year winter of abandonment and failure. This is the story of how AI was saved from the brink of extinction. The initial dream was born in the summer of 1956 at the Dartmouth Conference. The pioneers of the field made bold promises: thinking machines, automated translators, a world transformed within a generation. Their hopes were pinned on the first artificial neural networks, simple, elegant models called perceptrons. For a moment, it seemed to work. A perceptron could be taught to recognize simple patterns. It was a proof of concept that electrified the research community. But the hype was built on a fragile foundation. In 1969, AI pioneers Marvin Minsky and Seymour Papert published their book, Perceptrons, which delivered a devastating mathematical proof. They showed that these simple networks had a critical, fatal flaw. They were fundamentally incapable of solving a class of problems known as XOR problems, problems that were trivial for even the simplest biological brain. It was a dead end. The academic world reeled. Then came the killing blow. In 1973, the Lighthill Report, commissioned by the British government, officially declared the entire field a massive exaggeration and a failure. Funding from governments around the world vanished almost overnight. The world's top scientists abandoned the research. The AI winter had begun. For 20 years, the field was frozen, a scientific ghost town, haunted by broken promises. But in the frozen wilderness, a few refused to give up. Geoffrey Hinton, Jan LeCun, and Yoshua Bengio, now known as the Godfathers of AI, continued their work in obscurity, convinced that the core idea wasn't wrong, just incomplete. The problem, they believed, was depth. If a network with 10 layers makes a mistake, how does the very first layer know what it did wrong? This was the credit assignment problem, and for decades it remained unsolvable. The solution, rediscovered and championed by Hinton's group in the 1980s, was an idea of profound mathematical elegance: backpropagation. The idea was simple. You take the error from the final output, the measure of how wrong the AI was, and you send a signal backwards through the entire network. With each pass, every single connection in the network learns from the mistake and makes a tiny adjustment to its own internal weight. The AI was literally learning from its failures. It was the key, the engine that could power true artificial intelligence. But for years it was an engine without fuel. The thaw only began when two other unrelated technologies finally caught up. First, the explosion of the internet, which provided an ocean of data for the AI to learn from. And second, the rise of video games, which led to the creation of the Graphics Processing Unit, or GPU. Researchers discovered that the parallel architecture of a GPU, designed to render millions of pixels at once, was perfectly suited for the massive calculations required by a deep neural network. Suddenly, the engine had fuel. In 2012, a deep neural network named AlexNet, using backpropagation and powered by GPUs, entered the world's premier computer vision competition. It didn't just win, it shattered the previous record by such a massive margin that the entire field was changed forever. The AI winter was officially over. This was the ignition point. The same principles allowed DeepMind's AlphaGo to defeat the world's greatest Go player with Move 37, a move so alien and creative it was initially thought to be a mistake. It revealed that AI could not only calculate, but could intuit. And this same engine, combined with a new architecture called the Transformer, which gave AI the ability to weigh the importance of different words in a sentence, finally allowed it to understand the context and flow of human language. This led directly to the chatbots, image generators, and video creators we see today. So when we see an AI create a masterpiece from a single sentence, it's not magic. It's the legacy of a handful of researchers who refused to let an idea die in the cold. It's the echo of an elegant algorithm, learning from its own mistakes over and over again. The technology that was once a failed dream is now a tool of infinite creation, and that engine is only just warming up.